This is a very quick video for the Unit 4 test on the last 4 problems. This is number 17. For number 17, your answer should look like this. So there's an example answer where x is equal, the whole is x equals 6, the vertical asymptote is x equals -3, and the zero is x equals -1. Your answer needs to look like that, except for the whole, you need to have x equals 3, and for the vertical asymptote, you need to have x equals -4. All right, so instead of 6, you're going to have 3, and instead of -3, you're going to have 4. And it doesn't matter, you can put in anything you want for the 0. This example has x plus 1. You could use that or any other number you wanted for your 0. And that's how to answer number 17. This is a help chart for how to do 18, 19, and 20. All right, 18, 19, and 20 ask you for these 5, 6 things that are on the left. Horizontal asymptote, a whole, a 0, a vertical asymptote, and a chart. Those 5 things. All right, I'm going to go through them one by one. All right, so first a whole, or sorry, first a horizontal asymptote. So for a horizontal asymptote, we look at that value right there. All right, we don't care about any of this other stuff, but we look at that value right there. This says x squared over x cubed. We go to our chart over here, we find x squared over x cubed, which is right there. And that says when you have x squared over x cubed, the answer is y equals 0. So that's how you find the vertical asymptote. Next is the whole. So we look and see if we can cancel anything in this expression. All right, so we can cancel this x plus 5. All right, so that means there is a whole at x plus 5. Now, we don't say x plus 5, but we take whatever value x plus 5 equals 0, which is going to be the opposite of that. All right, so we use the opposite value from x plus 5. And that's your whole. After you cancel, your 0, or there could be more than one, your 0 is going to be in the numerator, and your denominator, in this case, there are 2 zeros. And the denominator is your vertical asymptote. All right, and the same thing applies to all of these. So this 0 says x minus 3. All right, so in this case, in our example, the 0 was x plus 1. So our x is actually x minus 1. So it's the opposite of the expression. In our example here, our vertical asymptote is x plus 4 because it's in the denominator. And in that case, we're going to have x equals -4, so the opposite. All right. Also in this one, if you have an x by itself, then your answer is x equals 0. That's for an x by itself. All right. The last thing is how to do the chart. So to match the chart, find the chart, you match the whole. All right. And so in this one, our whole was at x plus 5. All right, so this was our whole, was x plus 5. All right, and that meant that our whole was at x equals -5. And so we're looking at the charts here, and we're looking to find a hole. Now these little marks right there, those are the holes. All right. And you can tell by counting over how far they are. This hole is at -5 and this hole is at -2. And this one does not have a hole, right? So there is no hole in this graph. And you can use that to match the graph sum. All right. So just to go very quickly through these again, the first step is to look at the first two terms and see which one they match. And depending on which one they match, that's your answer. Second step, cancel. If something cancels out, that is a hole. It may be that something doesn't cancel out, in which case you would say none for the hole. All right. And notice in the case of x in horizontal asymptote, x/3, x³/x² is also a none. All right. This is how you do with zeros. They're in the numerator. There can be more than one. All right. Here's vertical asymptotes in the denominator. There can be more than one. All right. So make sure, and the question will ask you to identify. If there's two of them, it'll ask you for two of them. All right. And that is how you do 17, 18, and 19.